For the past few years, the AI industry has been obsessed with size. The assumption was simple: bigger models are smarter models. This led to massive, trillion parameter leviathans running in colossal, power hungry cloud data centers. But this centralized cloud AI paradigm has a fundamental flaw. It doesn't fit the constraints of the real world. Every time you ask a cloud model a question, your data makes a round trip to a server farm hundreds or even thousands of miles away. In industrial robotics, autonomous vehicles, or real time customer service, a delay of just a few hundred milliseconds is unacceptable. Add in environments with spotty internet connectivity or devices with strict power limits, and the cloud dependency becomes a massive bottleneck that stifles innovation and limits where artificial intelligence can realistically be deployed. Enter the era of local AI. In 2025 and 2026, the industry is experiencing a massive pivot. Instead of exclusively relying on massive centralized models, developers are adopting highly optimized small language models, or SLMs, that run directly on your smartphone, personal computer, or edge server. Gartner projects that by 2027, organizations will use these task specific SLMs 3 times more often than general purpose cloud models. Local AI isn't a downgrade, it's a critical optimization. It shifts the industry focus from how big can this get to can it run? Running advanced neural networks on consumer hardware sounds impossible until you understand how local AI optimizes memory. The biggest bottleneck in local processing isn't processor speed, it's video RAM or VRAM. VRAM acts as the critical counter space where model weights and context reside during inference. If a model is too big and spills over into standard system RAM, generation speeds plummet to unusable levels, often generating less than 1 token per second. To solve this, developers use a mathematical technique called quantization. Imagine taking a high-resolution photograph and compressing it without losing the main subject. Quantization does this to AI models. It maps high-precision, 16-bit or 32-bit floating point numbers into smaller 8-bit or 4-bit integers. This drastically slashes the memory footprint by up to 75% with barely any noticeable loss in reasoning quality. A massive 70 billion parameter model that normally requires 140 gigabytes of VRAM can be squeezed into just 40 gigabytes. This breakthrough is powered by modern unified memory architectures like Apple Silicon and highly specialized execution engines like llama.cpp. By packaging these compressed weights into highly efficient file formats called GGUF, local AI engines can dynamically balance the processing load across your CPUs and GPUs. This eliminates heavy dependencies, but does local AI actually make financial sense? The economics of artificial intelligence ultimately come down to a fierce battle between operational and capital expenditures. Cloud AI operates on a variable OPEX model. You pay per token or API request. It is perfect for prototyping and unpredictable workloads because there are essentially zero upfront infrastructure costs. Local AI flips this equation entirely. It requires a heavy initial capital expenditure, buying high-end GPUs, neural processing units, or massive local servers. However, once deployed, the marginal cost of running the model drops to near zero, no matter how much you use it. So, where is the break-even point? It all comes down to utilization rates. If your application processes fewer than 100,000 requests a month, the cloud will almost always be cheaper. But for high-volume scenarios like heavy coding agents, massive dataset analysis, or real-time document automation, local hardware pays for itself incredibly fast, sometimes within just 2 to 6 months. But be careful, simple math often hides operational realities. Running local server racks means paying for massive electricity bills, complex cooling systems, and the engineering labor required to maintain software and push updates. Because of these hidden costs, hardware investments are rarely justified on cost alone. The true value proposition of local AI comes when you combine long-term. The single biggest driver for enterprise adoption of local AI is absolute data sovereignty. When you use the cloud, sensitive data inevitably leaves your network. With local AI, the model operates completely air-gapped. Proprietary source code, patient health records, and confidential corporate strategies never leave the physical device, making it vastly easier to comply with strict regulatory frameworks like GDPR and HIPAA. But moving AI out of the cloud also transfers the security burden directly back to you. Running models locally introduces severe supply chain risks. For instance, downloading untrusted models in legacy Python pickle formats can lead to malicious code execution upon loading. That is why the industry is aggressively rushing to adopt secure, specialized formats like safe tensors. Furthermore, autonomous local agents with access to your file system are highly vulnerable to prompt injection, where a maliciously crafted document could trick your AI into. Despite these security risks, the barrier to entry has completely evaporated. Tools like Llama, LM Studio, and GPT-4 All have replaced complex command line coding with simple one-click graphical interfaces, letting absolutely anyone run powerful open source models like Alibaba's Qwen, Google's Gemma, or DeepSeek directly on their everyday laptop. But this consumer accessibility is just the beginning. The future of AI is rapidly moving toward a highly distributed hub and spoke architecture. At the edge, ultra-efficient silicon will power always-on smart devices, wearables, and industrial IoT sensors, handling real-time, low-latency tasks. Your smartphone or PC will act as a local hub, securely processing your daily cognitive tasks and organizing highly personal data. And the massive cloud won't disappear. It will simply serve as an escalation point for incredibly complex reasoning problems that your local hardware simply cannot solve. Ultimately, local AI is laying the crucial foundation for the agentic web. Instead of just chatting with a browser window, you will have a localized master agent living on your device. This agent will seamlessly orchestrate dozens of specialized micro agents to autonomously navigate the web, use enterprise software, and execute incredible. If this breakdown helped, like the video, subscribe for more explainers, share it with a builder who cares about better AI workflows, and I will see you in the next one.